Good morning all. Now I am continuing the CO2 second topic, that is nothing but the D beams, continuation to the previous one. So here you can see the truss model while designing, whereas L is the length of section and H is the depth of the section. So here we are applying the 2-point loading, that's why here the load is applied as WL by 2 whereas WL by 2. So in the case of truss model, the theta you have to maintain it as 68 degrees if the L by H is less than 1, and otherwise if the L by H, length by H ratio, it should be equal to 2, then you have to go for using the 54 degrees centigrade, 54 degrees theta angle you have to maintain. And coming for next one is the redefined truss model. So here the load is applied 4 points, so that's why here it is given as WL by 4 at each span. And here we have maintained, you can see 15 degrees in between the nodal points we will be applying the degrees. And next one, this is the arch section. You can see arch section in simply supported D beam. You can see here the loading is applied both from the top portion at the center portion of the arch, okay, that is not at the end portions. The load is applied at the center portions of the arch. And you can see the cracking pattern. As I said, whenever the top load is applied, you will be getting the flexural cracks which is coming from the bottom portion, and you can see the crushing portion, it is clearly shown in the figure. And whereas the D beams with uniform loaded from the bottom edge, so in the case of stress trajectories also, so here also the shear stresses are developed throughout the entire beams, which is evident in the figure A. And whereas in the case of the truss model, you can see here at the top portion you will be getting the compression, and at the bottom portion we are getting the tension. Whereas in the case of redefined truss model, so here also you will be getting both the compression as well as the tension zones, both are present. And if you can see the crack pattern, so you are getting the if you are applying the bottom load, rather than getting the flexural cracks, you are getting the shear cracks coming from the bottom portion to almost all the throughout the beam. And like what is meant by D beams as per IS 456 is, a beam shall be deemed to be a D beam. So I mean a beam should be called as a D beam when the ratio of effective span to overall depth, that is nothing but L by D ratio, is less than 2, that is for a simply supported beam. And if the L by D ratio is less than 2.5 for a continuous beam, if this condition is satisfied, then only that beam shall be called as a deep beam, otherwise it should be called as a normal beam only. And coming from the what is the lever arm, that is Z value for simply supported beams. So Z is equal to 0.2 into L plus capital 2D, when L by D should be in between, it should be less than or equal to 1 and should be less than or equal to 2, or if Z is equal to 0.6 L, when L by D ratio should be less than 1. The same case the lever arm for continuous beams, Z is equal to 0.2 into 1 plus 1.5 D, when L by D should be in between less than or equal to 1 to 2.5, or Z is equal to 0.5 L, when L by D should be less than 1. So these are the lever arms equations for simply supported beam as continuous beams under different span conditions. And coming for the next one, what is meant by positive reinforcement. So the tensile reinforcement required to resist positive bending moment in any span of a deep beam shall have the following characteristics. So first one is extend without curtailment between the supports. Next one is it should be embedded beyond the face of each support, so that at the face of the support it shall have a development length not less than 0.8 LD, whereas LD is nothing but the development length. So it should be placed within a zone of depth equal to 0.25 D to 0.051 adjacent to the tension face of the beam, where D is the overall depth and L is the effective span. So, this is about the positive reinforcement in the case of the D beams. And coming for what is meant by negative reinforcement in the case of D beams. So, for tensile reinforcement required to resist negative bending moment over a support of D beam, it shall be permissible to terminate not more than half of the reinforcement at a distance of 0.5 D from the face of the support, and the remainder shall extend over the full span. If you take the negative reinforcement distribution, when ratio of clear span to overall depth is in a range of 1 to 2.5, tensile reinforcement over a support of a beam shall be placed in two zones comprising a zone of depth 0.2 D adjacent to the tension face, which shall contain a proportion of the tension steel given by where L is equal to clear span and D is equal to overall depth. So, a zone measuring 0.3 D on either side of the mid depth of the beam, which shall contain the remainder of the tension steel, which is evenly distributed. So, for a span to depth ratios then unity, the steel shall be evenly distributed over a depth of 0.8 D measured from the tension. So, you can see here this is the placement of the tension steel in D beams with a case of 0.2 D, 0.3 D, and you can see here that is the positive steel. Next one you can see the negative steel with 0.25 D to 0.05 L, and next one B is the second case in the case of so just I am quickly revising things what we have seen. So, coming for the arch section. So, in the case of arch section, that is a simply supported beam which the loading is applied at the center portion, that is from the top portion. You can see the crack pattern. If the top load is applied, the crushing will be starting from the bottom portion of the beam. And coming for the stress trajectories, those will be uniformly distributed throughout the beam. And in the case of truss model, we can have both the compression as well as tension phases. Same in the case of refined truss model also, we will be getting both the compression as well as the tension zone. And coming for the crack patterns, so here we will be getting the crack patterns in the case of the shear cracks. So, coming for the definition of the deep beam, as per IS 456, a beam shall be called as a deep beam when the ratio of effective span to overall depth ratio, that is L by D ratio, should be less than 2 for a simply supported beam, and it should be less than 2.5 for a continuous beam. And whereas coming for lever arm for simply supported beam, it is Z is equal to 0.2 into L plus 2D, whereas L by D should be less than or equal to and between 1 and 2, and if the Z value is 0.6 L, when the L by D ratio should be less than 1, whereas for continuous beams the Z is equal to 0.2 into 1 plus 1.5 D, whereas L by D is equal to should be less than 1 less than or equal to 1 to 2.5, and Z is equal to 0.5 L, whereas L by D should be less than 1. And coming for the positive reinforcement, the tensile reinforcement required to resist positive bending moment in any span of the deep beam shall extend without curtailment between the supports. It should be embedded beyond the face of each support, so that at the face of the support it shall have a development length not less than 0.8 LD, whereas LD is the development length. It should be placed within a zone of depth equal to 0.5 D to 0.051 adjacent to the tension face of the beam, where D is the overall depth and L is the effective span. And coming for termination of the reinforcement, for tensile reinforcement it shall be permissible up to a distance of 0.5 D, whereas when the ratio to clear span to overall depth is in range of 1 to 2.5, so a zone of depth 0.2 adjacent tension face should be proportion, whereas L is equal to clear span and D is the overall depth, and also a zone measuring of 0.3 D should be given, whereas for span to depth ratios less than unity, the steel should be evenly distributed over a depth of 0.8 D measured from the tension. This is what is the second topic in CO2. Thank you all.